So in physics we come across different types of physical quantities. In mathematics we call all these quantities to be variables. So that is the same. Physical quantities we call in physics, in mathematics we call all them to be variables. So and therefore there exist some functions we call dependent function, independent function. We discuss various functions and this functions between variables, then differentiation, partial differentiation, etc. things already we have discussed in chapter 2. Now these physical quantities are broadly classified in two groups. One is called as scalars and second group is called as vectors. Okay, and we always know the physical quantities which are required to be specified by its magnitude as well as nothing, okay, only magnitude. We need to specify only magnitude, then this quantity is called as scalar quantities. For example, mass, it has a unit, okay, mass is expressed in kilograms or grams, but it doesn't require any direction. Similarly, time as well as temperature. So these are the physical quantities. There are not many other. These are called as physical quantities which doesn't require to specify by its direction, only magnitude is sufficient, and all these quantities are called as the scalar physical quantities or scalar variable in terms of mathematics. Whereas here we require, in vectors we require magnitude to be specified and direction. So there are two attributes are needed for these physical quantities to specify its completely. So complete specification of these physical quantities is possible only when we specify its magnitude as well as direction, and there are several common examples. As we know that velocity, then displacement, okay, first we should write displacement, then sector called this force, momentum, etc. So all these quantities which are needed to specify their magnitude as well as direction, and therefore these quantities are called as vector physical quantities or variables. In this case, if we call in mathematics, they are called to be vector variables. So actually we don't use this vector variables words, but in physics we call scalar physical quantities and vector physical quantities, and in mathematics all these are called as scalar variables and vector variables. Remember, now what is the basic difference? This difference we have understood. Apart from that, mathematics of this, that means algebra of scalars and algebra of vectors, they are different one. That is, if I go for simple addition, then subtraction, then multiplication and division. So these are the four simple operations of scalar that are known to us. So if I have two scalars, one is 5 and second is 3, I add 5 plus 3, that gives me 8. This is the same answer for all. कोणी जरी उत्तर काढलं तरी 8च येणार आहे. If one goes for 5 minus 3, this will be 2 for all. If we go for 5 into 3, this will be 15 for all, and 5 upon 3 is something 1.33 or whatever. This will come here. So this particular algebra doesn't change for anyone, and as long as the physical quantities I am expressing which are the scalar ones. So these operations are very well known to us. We use these operations several times in our everyday life as well, and these operations are called as algebra of the scalar physical quantities or scalars, so numbers. So that also can be shown by this example. But here addition of vector A and vector B is not same for all. Okay, it depends upon different other parameters. That's why this addition, subtraction, multiplication and division, actually this division is not defined here. So division of vectors is not defined. It is well defined in scalars, but in vectors divisions of vectors is not defined. So we have subtraction, we have multiplication, and multiplication also results in two different things. So when I multiply two vector quantities in such a manner, I get the product of this vector is scalar, vectors is scalar, then this is called as a scalar product. And when I there is some other technique wherein I will get the multiplication of these two vectors gives again as a resultant quantity, physical quantity is a vector, then it is called as a vector product. So that shows you, this particular thing shows you the addition, subtraction and multiplication that is to be carried out in case of vectors is totally different than what we carry out in case of scalars. So scalar multiplication, vector multiplication, these multiplications are altogether different. So in scalar multiplication 5 into 3 is always 15, but in vector it is not guaranteed it will be 15 all the time. It may have different values depending upon different circumstances. So in that sense, this vectors and scalars, that is what to be differentiated here. Okay, apart from that, we are not going to talk anything about this vector analysis here, because that is the second part of this chapter. We will discuss in detail when we go further. Okay, now that is, let's write in very brief the definitions which are required for that. So definitions, already we have discussed this, but write in one or two lines. First one is scalars. Okay, so write the definition: physical quantities which are completely specified, physical quantities which are completely specified, which are completely specified by magnitude, are scalar quantities or scalars, are scalar quantities or scalars, Okay, examples as we have discussed earlier, it is time, then mass, and we can have temperature, etc. So these are the examples of scalar physical quantities or scalars. Second, vectors. So write it down. You can write this very easily: physical quantities which are completely specified by magnitude as well as direction. Okay, so repeat this: physical quantities which are completely specified by magnitude and direction, so we have to specify direction all the time, are vector physical quantities, So as I said, there can be several examples: velocity, acceleration, momentum, etc. Velocity, acceleration, every physical quantity has different symbol as we know, then momentum, etc. This is one way of defining the vectors and scalars. Once we go for these definitions, now we'll go for certain other attributes. Now how to represent a vector on paper? So that is called as geometrical representation of vector. Geometrical representation of a vector. Geometrical representation of a vector, given a title. And you remember, or I think you might have seen earlier times, we have used some very interesting things earlier. We add mathematics here. Okay, we'll add this. Now this is what, a very simple, draw a two-dimensional space here. There are two axes, two-dimensional space. This is, I am calling to be x-axis, this is going to be y, and let this point P to be represented by these coordinates x and y. And now whenever I draw a vector, this is origin 0, 0. When I draw a line joining this origin and this point, okay, actually it's not going correct here. Okay, let's call this to be point P and not this. So this is we draw a line joining origin on and this point with this arrow. We call this to be a vector a bar representing point P, or this vector a bar is called as position vector of point P in the two-dimensional space as shown by this particular diagram. So this is the way we represent a vector on the plane or on the paper. So whatever point on that particular xy plane, each and every point will have its unit vector that will join this particular point from the origin. Therefore, this is only way where we can represent this any vector in this particular case. Okay. Now that is what straight line with an arrowhead. Okay. A straight line. STRAI GST, straight line with a arrowhead. Okay, this represents you to be a vector, and so this is OP bar. Okay, I am showing here, and this is represented by OP bar. This, or that is what A bar is equal to OP bar. Now remember here, some books give this sign vector, that means arrow over this letter or the symbol for the vector. Some book use this to be capital letter and dark one, okay, bold letter. So that is also is vectors here. So other things you might be knowing that sometimes we use this A bar. Some people only write this to be A bar like this. So this is what, this is a vector, this is also vector, this is also vector, this is also vector. So no need to worry about this type of symbols whatever you are used here. So this representation of vector on the graph or on the paper is done by this method. So we have to select a point P having its coordinate x and y. So draw a line joining this origin and that particular point. So it is called as position vector, represented by vector OP bar. So it has direction as well as it has magnitude. For other, if I have this point Q, another point x and x1 and y1, this is another point. So its position vector will be different than this, and this is how this vector will be now B vector. Now magnitude of this is different, the length of this will be different, as well as direction made by this vector with compared to this vector is also different. So these A and B are different vectors, they are not same, they are not, that means the vectors A bar and B bar which are representing point P and Q are different vectors. So their magnitudes may same but their directions are not same. So these are the different vectors. So that's what we have to understand this particular concept here. Actually we have used this particular concept very many times. So further classification or types of vectors. Types of vectors. Now there are two types. First one is called as polar vectors. Polar vectors. Most of you may not be knowing this definition. Okay, so this is what we'll write this definition first and then we'll discuss. Vectors like displacement, velocity, force, etc., which point towards the direction, points towards the direction of physical quantity, are called polar, or there is one more word, polar or radial vectors. Okay, across the radius, along the radius, along that direction of physical quantity, they are either called as polar vectors or radial vectors. This is first definition, first type, and second type is axial vectors. So you might have used earlier this right hand rule in lot many situations. Right hand rule. So there are some vectors which are shown along direction of the rotation. For example, in case of rotational motion, if I am having this rotational motion, This is axis of rotation we draw. So this is passing here. So if in this case I call this to be a V, mass of that particle is mv, and V into m, that is going to be a product, that is the momentum, and this momentum vector can be represented by this here. So this vector can be represented by a vector drawn at this here. So this is called as angular momentum. So r bar, actually this r cross product etc. we have not learned earlier, but as we learn this will make it more clear. So this vector which is drawn along, so in this case angular momentum of this rotational motion is a vector shown along the direction of this axis depending upon this motion. That means if it is this anti-clockwise motion, the vector will be directed upwards. If it is clockwise direction, then the vector may be directed in the downward direction. So this upward direction and downward direction, and the vector is drawn along the axis of rotation. So such vectors are called as axial vectors. So here in case of first polar case, there is no need, the vector itself is pointing the direction of that vector physical quantity, but here the physical quantity is somewhat different, but its vector is drawn along the axis, so that is called as axial vectors. Okay, so write in brief: vectors associated with rotational motion, vectors associated with rotational motion, vectors associated with the rotational motion, okay, like angular velocity, then torque, angular momentum, etc. Angular momentum, etc. are called axial vectors. Axial vectors. AXIAL. Axial vectors. So why this is this way? Because these vectors, write in brief, these vectors are represented along the axis of rotation. These vectors are represented along the axis of rotation. Remember, so here we have to use this right hand rule. Okay, so this right hand rule means in the direction. So curl your your fingers. Curl means आपल्या हाताची बोट अशी थोडीशी गोल करा, मूठ आपण करतो तशी. So in the direction of rotation, and whenever this rotation direction is represented by these fingers, now your thumb will represent the direction of this axial vectors, angular momentum or whatever this angular velocity etc. This will be represented by this right hand rule. His motion उलट असेल, that will be down. So you can use right hand rule, and that shows you how this actual vector goes this particular way. Okay, so that is how we have to remember these things as shown by this particular right hand rule, and that accordingly it is called as axial vectors and like that. So these are the two basic types. Now further things we have to go for different properties. Okay, so go for properties of vectors. Properties of vectors. After classification we will go for properties. Actually this is called as terminology used in vector analysis, so we'll go for that. First one is a unit vector. Unit vector. As we all know, in case of XYZ coordinate system, we have I cap, J cap and K cap. So this I cap is called as unit vector along X direction, J cap is the unit vector along Y direction, and K cap is called as unit vectors along K directions. So all these are known to be us. So this magnitude of this vector is unit 1. Magnitude is 1, and direction are along x-axis, y-axis and z-axis. So we call them to be unit vectors along the Cartesian coordinate system, or of the Cartesian coordinate system along 3 different directions. Okay, and we may know that every unit vector is represented by this cap. So I cap, J cap, K cap, etc. So this is the way how one represents these unit vectors. Whenever we call it to be a unit vector, it will have a certain direction, fixed direction, and magnitude of all these unit vectors is taken to be 1. Now for any ordinary vector, if I am given some vector A, we can calculate its unit vector by this following methods. Right here, a given vector say A bar, given vector say A bar in terms of unit vector, okay, I'm calling to be n cap. Say n cap in its direction is you might be knowing all this relationship. A bar is equal to n cap into its magnitude A. Okay, and that's what we can write this as, or for any vector its unit vector can be calculated by the simple method, that is vector itself divided by its magnitude. That is known to us, it is nothing new for us. So what is the first statement? Vector A bar is in terms of unit vector n cap in its direction is. So if this is my vector A bar, then if I draw n cap here, so this is n cap, this only. Okay, for that, getting this, I have to go for magnitude of this this vector A bar divided by its magnitude. Okay, this is actually its magnitude. Then I get, this is nothing but the unit vector. So direction of this unit vector and direction of this vector A is the same. Magnitude of this is much larger, and magnitude of this A n cap is just 1 unit. So in that sense, this is defined by unit vector. We can understand. You have used this particular definition several times earlier, so we need not go for this. Second second property, that is called as zero vector or null vector. Very simple things. We are not doing anything new here. Zero vector or null vector. Now what is this zero vector or null vector? If the initial and terminal point, if the initial and terminal points of vector are coincident, means that the initial and terminal points lies at the same point, that is called as coincident. The vector is called as null vector. The vector is called as null vector. Okay, so for example, I can give here example, position vector of origin. Position vector of origin is null vector. Position vector of origin is a null vector. Okay, it has zero magnitude. And no direction. It has zero magnitude and no direction. So this is the second property of the vector, which is called as the zero or null vector. Then third, we can go for equal vectors. In spite of writing this definition, I can draw this diagram. Now this is vector A bar, another vector B bar. So to have these vectors to be equal vectors, what must be common? Their magnitude. The vectors having same magnitude and same direction. Directions. Both are pointing in the same direction. Both are having same magnitude. Therefore, I can call this to be vector A bar is equal to B bar. These are called as equal vectors. They must be same. Then fourth is negative vectors. Negative vector. negative vector is, okay, vector, this a bar is this vector a bar, and this vector, if it is drawn exactly of the same length but opposite direction, this is called as minus a bar. So a bar and minus a bar, negative vector. So a bar is said to be negative vector. So negative vector must have its direction, magnitude is same, magnitude is same, that means length of the vector is same, directions are opposite, directions are opposite. This is the negative vector. Then position vector already we have discussed, we will not go into like that. Then next is I'll just take 1 or 2 minutes, we'll come finish this and then we'll come to other points. So next is the like vectors. 5 like vectors, they are like each other but they are not equal vectors. So I will draw this simple picture. This is my a bar and this is b bar. So here direction is same, okay, magnitude is different. Direction is same, magnitude is different. Then unlike vectors, then there is unlike vectors. So just draw the opposite figure to this. So this is vector a bar and I am drawing this is vector b bar. So now unlike means they are not like at all, so their directions are opposite or different and their magnitude is also different. Both direction and magnitude are different. Directions and magnitudes are different. Then 7th, that is coplanar vectors. Coplanar vectors. Okay, vectors lying, L-Y-I-N-G, lying in same plane. Vectors lying in same plane are called as coplanar vectors. Okay, so I'll draw this vector here, this vector, this vector. They are all in same plane. That's why this is called as coplanar vectors. Sorry. Okay. So friends, and opposite to that 8 non-coplanar vectors. Okay, so vectors lying in different plane, in different planes. This is this. So today we'll stop here as 12 o'clock. Now tomorrow we'll go further.